Before we go into possible theories as to why plates actually move, what I want to do in this video is think a little bit about why we see the geological features we do see at plate boundaries. And in particular, I want to focus on the features we see at divergent plate boundaries, where the plates are moving away from each other, or where new land is being created, like we saw in the mid-oceanic ridges, where we see new land being created right in the center and moving outwards from them. So to do that, let's think about the different layers. And actually, I want to make one quick correction on the last video. Over here, I had drawn these arrows going in that direction. And based on how I defined them, they should be going into the page. And so they should have had these X's there. Now, with that out of the way, let's draw a little diagram of what happens at at the early stages of these divergent plate boundaries. So you might have here you have just your crust. And maybe it's continental crust. So this right here is the Earth's crust. And then you have the solid part of the mantle, and the combination of them is the lithosphere. And then you have the liquid part, or the super hot part of the mantle. So this down here is magma. It hasn't solidified. It's hot enough to be in the liquid state. And all of this combined, so this right here we consider the mantle. Now, there's some debate, and we'll talk about this in the next video, of how hot spots actually form. It could be these mantle plumes that start at the border between the mantle and the core. It could be some type of convection currents in the actual mantle. We'll talk more about that in the next video, or maybe a few videos from now. But let's take it for granted that hot spots form in the mantle. So let's say we have an area of magma right here that is particularly hot. Let me draw it. Let me do this in another color. I'll do it in pink. So this is particularly hot magma here. And we know, or maybe we don't know, well, you know right now, if you take the same material and you make it hotter, it's going to become less dense, because the particles essentially are going to bump into each other with more kinetic energy and have more space in between them. And so this really hot part of the magma, or this really hot part of the mantle, it is going to move upwards. It is going to move upwards because it is less dense. It will have buoyancy. And as it moves upwards, it'll heat up the things around it. And it'll eventually make its way into the lithosphere. And it'll kind of be able to break through the lithosphere because it's so hot, it can kind of melt its way through. So let's fast forward this. Let's fast forward this a little bit. So this is step 1 up here. Now step 2, this hot magma is rising now through the lithosphere. And so it's going to create a hot spot. It's going to create a dome in the lithosphere and actually on the crust. And so it might look like this. So the crust is now going to have a dome in it. And this is the original lithosphere. And it's now kind of been broken in two by this hot spot. So the lithosphere is now broken in two, or it's about to be broken in two by this hot spot. So all of this is still the lithosphere. I'll just write litho for short. This up here is the crust. And if you take any rigid material, and the crust and the lithosphere for that matter, they're rigid, and you push outward on it, it won't stretch nicely like a nice elastic balloon. It'll start to crack and have to be pulled apart in order to kind of take the pushing from below. So this crust is going to start to crack. And actually, the best example where you see this is actually in like sourdough bread that has really hard shells around it. You see sourdough bread. Let me see if I can draw a roll of sourdough bread. It has these cracks in the surface, and that's because the outer layer, the outer shell of the bread is really rigid. And so when the inside heats up and the surface area has to expand, these kind of rifts form. These rifts form in the bread to allow that kind of rigid shell to actually expand. And that exact same thing would happen to the crust, or actually the entire lithosphere. So let me draw this hot spot again. So now the hot spot, I want to do it in that pink color. Now the hot spot has gotten this far. This is the hot magma right over here. And if we fast forward a little bit, if we fast forward even a little bit more, then you could actually have the crust starting to be fully pulled apart. So you fast forward a little bit more, the bottom boundary of the lithosphere maybe now starts to look something like this. The magma has kind of broken through the hardened part, the rigid part of the mantle. So maybe it looks like this. Maybe it looks like this right now. You have the hot spot right over here. It's gotten that far now. It's gotten that far. And the crust on top, the actual, what we would kind of, what we normally see, has now been pulled apart to kind of have to cover this new surface area. So now it kind of looks something like this. So it's been pushed apart. Let me see how well I can draw this. So now it's been pushed apart. And as it gets pushed apart, it kind of thins out a little bit, as you can imagine it doing. It's almost exactly as the bread analogy. When you look at bread like this, the rift, the parts the depressions where it was expanding most vigorously, those parts of the bread are actually thinner. Like these parts of the bread are actually thinner, and they're not as hard as the parts that moved away. And you see that exact same thing happening with the land. And you see that exact same thing happening in land. And all of this stuff is going to start getting pushed. All of this stuff is continuously getting pushed outward, essentially to kind of make space for this hot spot. Now, at this step right over here, you might have a volcano or two, but more important, you're going to have what's called a rift valley. Right now, we're assuming that we're not below sea level yet, or we're assuming that this kind of depression in the land that you see here hasn't come in contact with another body of water. And so it'll just kind of become a little valley in between higher land. And you actually see that on Earth. And the most famous is the African Rift Valley that's right about this region here. Actually, I have a better diagram that depicts the African Rift Valley right over here. It's this whole region of Africa is actually kind of a big valley created by a hot spot right over there. Now, as the hot spot kind of keeps maturing, eventually some of the rift will become so depressed that it'll actually be below sea level. Remember, all of this land up here is being stretched apart. So let me go to the next step. The next step will be right over here. The land on top is now maybe below sea level on this next step, and it comes in contact with maybe an ocean or a sea. And so now it might look like this. So now the land is super thin on top. Do my best to draw it. So it's super thin on top, and remember, it's kind of keeps getting pulled apart. It keeps getting pulled apart from this bubble of hot magma that's coming up from below. Let me draw it like this. This is all solid rock here. What I drew in orange is the crust. This is kind of the rocky part. And actually, I shouldn't draw it. This is the rocky part of the mantle. So the combination is the lithosphere. And now you have the hot magma coming up like this. And it might peek through every now and then and create a volcano there. Maybe it'll peek through and create a volcano there. But in general, it's going to keep pushing the land up and outwards. And so this land, even though you're saying, hey, it's being pushed up, because of the outward motion, this land over here is going to be lower than the land around it, like the loaf of bread. If it gets low enough and comes in and below sea level, actually, and it comes in contact with a body of water, or even if it doesn't, actually, water will start to gather over there. Water will start to gather. And once again, we actually see that in the rift forming between the African and the Arabian plates. The Red Sea is actually an example of exactly that. The Arabian plate is moving away from the African plate because of this hot spot. This is pushing all of the land up and out right over here. And so this is going out, that is going out. It's moving outward in every direction. And so it creates these depressions where water can flow inwards. The Rift Valley hasn't had water flow into it the way the Red Sea has just yet. But if it kept happening, eventually it's going to get low enough so that the water will flow into it. So the Red Sea is exactly that. You essentially have the Indian Ocean flowing into this rift that formed from this hot spot. And then if you fast forward a bunch, so that finally the magma can kind of surface. So let's fast forward from even this point even more. So let's fast forward even more. And let's say now the land has been pushed a good bit apart. Now the hot spot is actually surfaced. Now the crust might look something like this. The crust might look something like this. So it's been pushed apart a good bit at this point. Now we're talking about in the order of hundreds of thousands of years or tens of thousands of years. So the land, for example, the land that was here, this part of the land might now be out here, and this part of the land might now be out here. What's going to happen is that this hot spot this hot spot is going to continue to fuel, and we're assuming everything's underwater at this point, since this depression that was created is now so low, the crust was stretched thin. We're going to assume that all of this is underwater. The hot spot is essentially going to come out of underwater volcanoes. It's going to come out of underwater volcanoes and start creating what's now, this body of water has gotten large enough that we could call it a mid-oceanic ridge. And so it'll actually start creating, let me do this in a different color. It'll start creating an actual ridge. It'll actually create a ridge with volcanoes in the center. And so that's why, one, we see things like the Rift Valley in Africa. We see things like the Red Sea. And maybe even more importantly, that's why we see something like the mid-Atlantic Rift in the middle of the Atlantic Ocean, where you have all of this depressed land that was essentially analogous to that Rift Valley, but it's at a much later stage. And that's why it's able to collect water, because when the land was pushed out and stretched thin, water was able to flow into it. Going back to the bread analogy, it's essentially when this bread was baking and this part of the surface, the crust, pushed outwards, you had this rift form. And then if there was some water on the bread, if it was raining or if it was connected to a body of water, water would have eventually flowed in here. And if that bread kept growing, this rift would have kept growing, eventually to the size of the Atlantic Ocean in our theoretical bread. And so that's why you have this huge depressed area where an ocean can form, but in the middle of it you kind of have this, actual submerged mountain chain, the submerged chain of volcanoes, this submerged ridge where the land actually does go up a little bit because of all that magma flowing directly out of it. So hopefully that clears up a little bit. That was always confusing to me, why you see uplifted land, but then everything around the uplifted land is much lower, and why the whole thing is submerged as it's moving away. So hopefully that cleared things up a little bit.